Energy of the future, renewable resources, and their potential. Imagine a world with endless energy and clean air. It's not science fiction, it's the near future, powered by renewable resources. Welcome to a world where the future of energy isn't a distant dream, but a tangible reality. For decades, we've relied on fossil fuels, coal, oil, natural gas. They fueled industrial revolutions and provided our comfort and progress. But this coin has a dark side, growing more apparent and concerning each year. Consider the scale. Billions of tons of carbon dioxide are released into the atmosphere annually, accelerating climate change and creating a greenhouse effect. Our cities choke on smog, and ecosystems suffer from pollution, threatening biodiversity. But it's not just about ecology. Fossil resources are finite. We extract them from the earth, and one day, they'll simply run out. Moreover, their deposits are often concentrated in politically unstable regions, making global energy security fragile and vulnerable. Energy prices fluctuate, impacting economies and our well-being. This is the energy crisis that forces us to seek new paths. These challenges have driven scientists, engineers, and policymakers to seek alternatives. We need energy that's clean, inexhaustible, accessible, and decentralized. Enter renewable energy sources, those that draw power from constantly replenishing natural processes. The sun, wind, water, geothermal heat, biomass, these immense, inexhaustible forces have always been here. Now, we're learning to harness them effectively. The shift to green energy isn't just a trend, it's a strategic imperative, the foundation for sustainable development in the 21st century. It's a path to energy independence, reducing our impact on the planet and building a healthier, safer future. We're on the cusp of a new energy era where every sunbeam and gust of wind can power our homes. This transition requires effort and investment, but the benefits are worth it. What if I told you the most powerful energy source is right above us, and we've learned to capture its rays? If there's one energy source truly inexhaustible in human terms, it's the sun. Our star radiates a colossal amount of energy every second, and only a fraction reaches Earth. Yet, even that fraction could meet global energy needs thousands of times over. The question is, how efficiently can we capture and convert it? Modern solar energy relies on photovoltaic cells or solar panels. They work simply and elegantly. Imagine a semiconductor material, usually silicon. When photons of light, tiny particles carrying solar energy, strike it, they knock electrons loose. These free electrons move, creating an electric current. This is the photovoltaic effect. Many such cells connected form a solar panel, collecting the sun's energy for our use. Solar installations come in various types and sizes. The most common are photovoltaic PV systems. They can be small, like those powering calculators or garden lights, or huge, covering entire fields, solar farms, or power plants. Panels can be installed on rooftops, integrated into building facades, or used to power satellites in space. PV systems are a versatile solution, generating electricity almost anywhere there's sunlight. Another type of solar energy is concentrated solar power, CSP. Unlike PV, which directly converts light into electricity, CSP systems use mirrors to focus sunlight on a single point. This heats a receiver to very high temperatures, turning water into steam. The steam then spins turbines, generating electricity like traditional power plants. These systems are large-scale and require lots of sunlight, so they're often built in deserts. Solar energy applications are diverse, from off-grid systems for remote communities to industrial giants feeding national grids. Solar panels power traffic lights, surveillance systems, and are increasingly accessible to homeowners seeking to cut energy bills and reduce their carbon footprint. Technological advancements and falling costs make solar energy a promising path in the global energy transition. We're learning to catch starlight to light our way forward. Prepare to rethink how the wind on your face can become a potent source of energy for millions of homes. Having explored solar energy, let's turn to another powerful and ubiquitous phenomenon: wind. Humanity has harnessed wind for millennia, from sailing ships to windmills grinding grain. But only recently have we learned to convert it into electricity on an industrial scale, transforming the energy landscape. Wind energy is based on a simple principle. The kinetic energy of moving air is converted into mechanical energy, turning turbine blades, which then power a generator to produce electricity. Modern wind turbines are high-tech structures, reaching enormous sizes, with blades spanning tens of meters and heights comparable to skyscrapers. The larger and taller the turbine, the more energy it captures, as wind is stronger and more stable at higher altitudes. Wind farms are groups of turbines located in areas with consistently strong winds. There are two main types: onshore and offshore. Onshore wind farms are generally cheaper to build and maintain, but face land use and visual impact limitations. Offshore wind farms, though more expensive, offer significant advantages: stronger, steadier winds, no obstructions, and no noise or visual pollution for communities. Located far from shore, they allow for giant installations and maximum output. Wind energy development is constantly evolving. Innovations aim to increase efficiency and reduce costs. Turbines are growing larger, new blade materials are being developed, and aerodynamics are improving. Smart control systems automatically adjust turbine angles to optimize wind capture. More exotic concepts, like airborne wind energy systems, use tethered aerostats or drones to harvest energy at high altitudes, where winds are even more powerful and consistent. Wind energy isn't just an alternative, it's a cornerstone of future energy independence. It already powers millions of homes worldwide, reducing emissions and strengthening energy security. Challenges remain, but progress is so rapid that the wind, once just blowing, is now working for humanity. Imagine hidden energy surging beneath your feet, rivers flowing eternally, and even ordinary plants becoming a source of light. While we look to the sky for sun and wind, these unsung heroes awaited their turn, ready to provide clean energy. While the world watches rooftop solar panels and giant wind turbines, other vital renewable sources quietly contribute to our energy future. These are water, geothermal heat, and biomass, each with unique characteristics and potential, completing the picture of green energy. Let's start with hydropower, the oldest and most proven renewable source. Humanity has used falling water for centuries, But modern hydropower has reached a new level. The principle is simple. Water stored behind a dam flows down, turning turbines. These turbines drive generators, producing electricity. Hydroelectric plants are reliable, quickly adjust output based on demand, and have long lifespans. They act as energy batteries, storing energy as water and releasing it as needed. Small-scale and run-of-river hydro plants minimize environmental impact. However, large HEPs can impact river ecosystems and displace people, requiring careful planning. Now let's look underground at geothermal energy. Our planet is a giant hot ball, and its internal heat can power us. Geothermal power plants drill deep wells to access hot water or steam under high pressure. This steam then turns turbines, generating electricity. Unlike solar and wind, geothermal energy is available 24/7, regardless of weather, making it a stable, predictable source. Besides electricity, geothermal heat is used for heating buildings, greenhouses, and water. Iceland is a prime example of a country relying heavily on geothermal energy. The main challenges are geographical limitations and high initial drilling costs. Finally, bioenergy, energy from organic materials or biomass. This includes agricultural waste, forestry residues, municipal waste, and energy crops. Biomass can be converted into energy in several ways: direct combustion for heat and electricity, anaerobic digestion to produce biogas, which can be used as fuel, and biofuel production, e.g., bioethanol or biodiesel, for transportation. The beauty of bioenergy is that it can use what would be waste, turning it into a valuable resource. In theory, biomass combustion is carbon neutral, as plants absorb carbon dioxide as they grow. However, sustainable biomass sourcing is crucial to avoid deforestation and competition with food production. These unsung heroes, water, geothermal heat, and biomass, complete the renewable energy picture, offering diverse solutions for a clean energy future. It's undeniable, the cost of producing energy from solar and wind has fallen by over 80% in the last decade, making them competitive with fossil fuels. But even with such a breakthrough, the path to a fully green future holds complex, costly challenges. Our journey into renewable energy has been full of discovery, but like any major transformation, the transition to green energy has its nuances, advantages, and of course, challenges. Let's look at them objectively. Renewable energy's advantages are numerous. First, ecology. The main threat to our planet is greenhouse gas emissions. Solar panels and wind turbines don't burn fuel or release CO2. That means clean air, less smog, and slower global warming. They also don't produce radioactive waste or pollute water, like many traditional industries. The second key aspect is energy independence. Countries relying on fossil fuel imports are vulnerable to geopolitical shocks. Developing renewable energy reduces dependence on external suppliers, strengthening stability. Solar and wind energy are available almost everywhere, enabling decentralized systems. And, of course, inexhaustibility. Unlike finite oil or gas reserves, the sun will shine for billions of years. A wind will blow, rivers will flow, and the earth will retain its internal heat. This gives us long-term confidence, without fear of resource depletion. Despite these benefits, serious challenges exist. The most significant is instability and intermittency. Solar panels don't generate electricity at night or on cloudy days, and wind turbines stop when there's no wind. This creates serious challenges for energy system stability, requiring constant balance between production and consumption. Hence the next challenge, energy storage. To smooth out peaks and troughs, we need large-scale, efficient energy storage systems like powerful batteries. Developing storage technologies is expensive and complex. Current solutions aren't always cost-effective or scalable. Another aspect is initial costs and infrastructure. While green energy costs are falling, initial investments in wind farm or solar farm construction remain significant. Existing grids aren't always ready to integrate many distributed, variable sources. Large-scale modernization and smart grids are needed. Finally, local environmental impacts shouldn't be forgotten. While renewable sources are generally cleaner, large-scale construction, example wind farms in bird migration routes, HEPs changing landscapes, can cause environmental or social problems. Solar panel and battery production also require resources. Thus, green energy isn't a panacea, but a complex path. It offers huge opportunities for a sustainable future, but requires innovation, investment, and careful planning to overcome challenges. Forget what you knew about electricity. The future of energy isn't knocking. It's bursting into our lives, offering technologies that seemed like science fiction yesterday, and promising a world transformed by clean energy. We've explored the mainstays of renewable energy, the power of the sun, the force of the wind, and the potential of water, geothermal, and biomass. We've discussed their benefits and challenges. What lies ahead? What will the energy world of tomorrow look like? One thing's certain, the future is here, and it's evolving incredibly fast, driven by innovation and the global pursuit of sustainability. New technologies are at the heart of the energy revolution. For example, Perovskite solar cells promise to be cheaper, more flexible, and more efficient than traditional silicon panels, opening doors for integration into windows, building facades, and even clothing. We're seeing floating solar farms on bodies of water and agrivoltaics, where panels are installed above farmland, allowing simultaneous energy and crop production. Wind energy is also evolving. New generation offshore turbines withstand harsh marine conditions and generate even more energy. High-altitude wind systems harness stable, strong air currents at high altitudes. Smart grids are key to the future. These aren't just wires, but a digital infrastructure that monitors energy production and consumption in real time, automatically balancing supply and demand. Smart grids integrate distributed renewable sources, predict their output based on weather data, and redistribute energy flows, increasing system reliability and flexibility. Progress in energy storage is equally important. The problem of solar and wind instability requires efficient batteries. Besides improving lithium-ion batteries, solid-state batteries promise greater energy density and safety. Flow batteries store large volumes of liquid. And of course, hydrogen is being considered as a versatile energy carrier of the future. It can be produced using renewable energy, green hydrogen, stored and used for transportation, industry, or electricity production when the sun doesn't shine or the wind doesn't blow, creating a flexible system where surplus energy is converted into hydrogen and back into electricity. Global trends show the transition is irreversible. More countries are setting ambitious decarbonization goals. Major corporations pledge to use 100% renewable energy, and investments in green technologies are breaking records. Artificial intelligence and machine learning optimize power plant operations, predict weather, and manage networks. The energy future is not only about technology, but also global cooperation, economic benefit, and, above all, care for our planet. We're on the threshold of a world where clean, accessible energy becomes the norm, not the exception. If you're inspired by this vision of the energy future and want to explore how our world is changing, subscribe to the Epoch Echoes channel and like this video to stay updated.